And I think that we are now recording this. Welcome to some artisanal programming, boys and girls. And so today, as the name implies, we're going to be talking about ANSI escape codes. And for this, we're going to be, implementing this in C. And I hope that you can see that I'm wearing a hat. We are artisanal developers after all, right? AI will take everything from everyone, so let's be happy until we can. So let's see what that will do. Anyway, we're going to be talking about artisanal programming in C, and so that we can start actually talking about the ANSI escape commands, right? As the name implies, they are escape commands. And what does that mean? That pretty much means that if I were to start writing some printf commands here in C, let's say hello world, and I need to remember to actually include, let me just do that so that I don't bother my amazing logo, right? Now that we have that, let's do make run. Say hello world is there, great, so it works. I can probably do a little bit better if I need to first of all insert the character called the backslash for my keyboard. For some reason he decided to break right today, but it doesn't matter. Make run. There we go. Hello world is there. And as you can see now, the program, my program, there we go. Hello world is there, right? So as you can clearly see there, the program is running. It's doing exactly what it's supposed to do. And we have hello world there. But the problem is we want to have a little bit more interesting things happening. So what are these ANSI escape commands? Well, for an example, the original \n that we have right here is in its way a command. The command is write myself a new line. So all of these weird things that the shell actually interprets in your terminal so that it can actually render these text things called letters, they actually go through the shell and the terminal emulator so that it can actually make some interesting decisions to your text. That way the \n makes a new line, the \b is a backspace, and so on and so forth. But then you're going to be telling me, but Ruben, what do you mean? Oh, no, this is small. Let me make it big again. There we go. So what happens is, every command should follow this syntax. Actually, no. For we have multiple commands that the ANSI structured, or the rules that they exist may need to follow, right? So what happens primarily is, for an example, let's say that we're going to be making now a simple experimentation to mix and to modify graphics inside of this environment that we have right now, right? And so for an example, then I want to say hello world, but I want to say that the hello word will be white as it is right now, but I want to make it red on the world side. So what I need to do is actually encapsulate the word world with something that is the structure of graphical implementation with the escape code. So obviously now the first thing that I need to do is actually write myself the escape key. So now how do I write myself the escape key? Can I just say ASC, but I need to do something different? So for that matter, what I'm going to need to do is, again, I don't have the \/ key anymore, so I need to borrow that. There we go, X1B. That is, one of the possible combinations that you can actually use as the escape key. And then what we need to do next is actually we need to structure this escape command by following the simple rule set. Let me just copy this so that I can show you a little bit better. So for us to have the rules of a command is we first of all need to specify that we have the escape key starting this command. Then we have the opening of such commands that are going to be available. Then we can actually type all of these as numbers as we might. But again, there's no such thing as the for blah, blah, blah number that I just said there as a real command. But we have like 1, we have 2, we have 3, we have all of these small commands that we can actually concatenate them and actually append them one next to the other. And the fascinating thing is we can do that for a multitude of them. Now, if we're going to make something that is useful, we're probably going to use multiple styles at the same time. Like I want to have bold letters, I want to have italic letters, but for the first moment, let's just change the coloring so that we don't, start getting crazy, right? And so the first rules that we need to remember are colors they are not an easy thing, especially for old school terminals, right? Because these commands, they actually came by to us. The first real implementation was the Xterm emulator, right? So this terminal emulator called Xterm, it brought us this implementation of these different commands and different rules that they had to be followed so that we could take advantage of something called coloring inside your terminal. Before that, we only had black and white. So let's just take a look at what these colors were going to be like. So back then, we had the 30s and the 40s. So we had 30 commands. So these are 30, 31, 32, 33, 34, 35, 36, 37. And if I'm not mistaken, there was 39. But we can probably take a look at that. So let's just let's just take a look at this now, and let's just see what that will do. So, oh, my bad. So let's just say, for example, what would 31 do? So if I were to do that, I need to do, first of all, this, open the commands, put the number 31 over there. And now, if we look at this, we can probably guess that we have something missing right now. Because, well, we're seeing that the structure itself has the command. We have the first escape key. We have the command initialization index, or whatever you want to call it. Some people call them CSI. And then we have the number itself, which identifies the command. But then you're going to be telling me, but Ruben, how do we define that we stop implementing commands? Why couldn't the word world be a command? Exactly. And so what we need to do next is we need to add ourselves the letter M to the end. This is what tells us, and more specifically, it tells the terminal and the shell that, well, this is exactly the command we're going to be using. And now, if I were to do that, we should have now the hello world with the word world in red, right? Cool. So this primarily is what we have to do now is, well, we already know exactly what this is. It's not that climatic, wow, it's amazing. But the cool thing is, well, we already have coloring now. What else can we do with this amazing thing called ANSI escape codes? Well, for starters, the escape key can come in many shapes and sizes. We just did, if I'm not mistaken, the hexadecimal value, but we can use it with many other different ways. We can use the octal value, which, if I'm not mistaken, is 033. We could use even the ESC if you're using Python, for Python does have its own implementation of the escape key as well. If I'm not mistaken, there's a library, or if I'm not mistaken, they have a macro for this, and that's where the macro culture shines in logging, right? Because one of the most used cases for this is obviously logging algorithms. So logging means to log out information from your application itself. And so what happens to us is, well, we can probably take a look at this and try and make our own implementation of a logging algorithm, right? Logging out information or printing information that we can actually use, or, have some fun with this. So let's just first of all define some macros right now. So these macros are we going to be using, as the name implies. They are just macro definitions, so we just need to do something like hashtag define. And so what we're going to do first is define the escape key. So the escape key, as the name we're going to be using, is something like this. So now we have the escape key. I can just replace this with escape. Obviously, this will not work for the string interpolation. We'll just say, well, that is the escape key, right? And so we need to do escape and do this. And if I'm not mistaken, that should work. If I'm not mistaken, that's great, right? So maybe that will work. I think it will. There we go. It did work again, pretty much, right? It's just a macro. It doesn't do anything else. And now that we have the escape key, we could do something a little bit better so that we don't need to use the CSI, the command initialization string, or I think there is another way. I don't remember the name of the thing called CSI. If I'm not, I think it's control sequence initializer, or an introducer, or initializer. I think it's initializer, right? Let's just go with control sequence initializer. So the control sequence initializer, or CSI, is this thing over here. So we can probably do this, but the cool thing is we can actually do this too, or escape the key to initialize the commands. But I do like them to have one next to each other like this. Again, it's whatever you want to call it. So in here we have the escape key, and here we have the control sequence initializer. I think it's initializer with a Z, or init, whatever. Let's just call it init. So now we have the CSI and the escape key. Now we can do is actually define some styling options that the terminal emulators will have their own definition, but most of them follow the standard, and the standard is pretty much the same one, which we go, if I'm not mistaken again, from 0 to 9, because if 0 is resetting everything, 1 up to 9 are the stylings available. So again, each individual terminal will have their styling supported. So we have blinking, we have bold text, we have italic, so we can have multiple ones. And if I can see on my cheat sheet, we have bold, dim, italic, underline, blank, inverse, invisible, and strike through. So let's define these right now. I will just yoink my own, my own cheats. And there we have it, right? So we have bold, dim, italic, underline, blank, inverse, invisible, and strike through, right? So as we can see now, we have all of these definitions. And as you can see, they start from 1, 2, 3, 4, 5, 7, 8, and 9. 6 is not existent. I don't remember why, but I do know that they do not have 6, right? And that happens as well on both the 30s and 40s as well. So let's just take a look at this right now and see what this will do. So if we know that the sequence for bold is just 1M, we can just go in here, and instead of saying 31 and escape and whatever, we can just change the world here and use, what was the name of the thing that call it? Bold. Let's just say that we have bold on the word world. Again, make run. And now we have the world with bold characters. Now, clearly, we cannot see it that well. We can only see here a bit. So let's just try and do something a little bit better and just say again, we're going to have bold and red. Now, does the order of these code commands matter? Let's see. So if we're going to say that I want to have bold, and I also want to have a new command, and that command will be the CSI again, will be the escape key, blah, 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 blah. But I want to have coloring now. So the coloring, we can do, 30 again. Let's just take examples. So what I'm going to do, because I am a bit lazy, let's just do define here. Let's just say foreground red. And so foreground red will be, as the name implies, CSI. And now, if I'm not mistaken, is 31. So it's 31M. Do that here as well. So we have bold, space, foreground red. And now, if I go down here, there we go. Now we have red coloring again. And so we do have the possibility to, again, append two values, one next to each other, and that you're just following the same structure of each individual command. And does the order of the commands affect the output? We have foreground red with bold. Let's see what that will do. No, it doesn't. So the effect is unchanged. So now we do know exactly that the A and the SI commands, they don't matter the order of execution as long as you execute them one next to each other, right? You cannot execute this one this time and in the future stop doing that right now, right after. Now the cool thing that we can try now is see what would happen if we apply the same commands first to the world hello and unchange the word, the world thing, right? So let's just see that. Right. So what I'm going to do next is I'll just do this, and I'll move this over here. And so by default, you're probably going to think to yourself, well, this will affect either both of them or only the first word. We are making, as we can see here, two different words. They're both strings. Well, we have three combinations of strings. We have the 4G red, 4G, we have the FG red, bold, then we have hello, and the world word, right? So my guess is that it will apply to both words, but that's just my guess. You can probably have your own. Let's see what that will do. 1, 2, and 3. It applies to both of them, right? Because what happened is the graphical commands, they apply to everything in the sequence of them, but we do have control over how they are applied. And as again, we decided before, we should have a command as well to reset everything, to stop the execution of all the commands that came before it. So in graphical terms, we started at 1 for the bold one. Let's just do 0 and see what happens. 0 should probably be the reset key, right? And you can probably guess that that is true, right? So let's just change the word bold here to reset. I'll just reset everything. And now, if I were to reset this, I need to define where I'm going to reset it. So if I were to reset in the halfway of the word hello, I could do that. So I can do this for an example. So half of the word hello would be in red and the other half will be in white. And so that would do something similar to this. Hello, well, with hell in red and then the lo in white and the word world. The word world would be in white as well, right? So let's just try and make some interesting experimentation now and apply the same rules now to every color available on the standard ANSI table, right? So by default, you have probably heard of true color, right? True color means that we have terminals that have support to all colors in the range of 0 to 255. And so those true colors mean full RGB support. We can go beyond just the first definitions of the terminal, right? Which by default, if I'm not mistaken, they are black, white, red, green, yellow, blue, cyan, magenta, and I will not remember now by head, but hey, we do have my cheat sheet, so let me see which one they are. They are black, red, green, yellow, blue, magenta, cyan, and white, right? I think I forgot cyan, but it doesn't really matter. So let's just use the amazing experimentation of getting my cheat sheet to work. So we have this, and now I'll just change the foreground definitions that we had over here, and now we have all the definitions of color. And as you can see in here, they are all the 30s. So we have 30, 31, 32, 33, 34, 35, 36, and 37. Now, different from the original, let me go back here, from the original styling that we had available, you can clearly see that the 6 does not exist, but here it does. Again, don't ask me why. The Xterm guys, they do have a very interesting experimentation for terminal emulators. It is really well written, but it's hard to understand why the 6 doesn't exist. But hey, it's part of life. Maybe we just need to embrace it. So we first have the FG one. So FG changes all the foreground coloring, but we can also change the background coloring as well. So the backgrounds, again, instead of the 30s, they are the 40s. So again, we're just going to do the same thing. Again, cheat sheet, the amazing cheat sheet. They allow me to show you the 40s now. The 40s, they are just black, red, green, yellow, blue, magenta, cyan, and white again. But now applying to the background. Now you're going to be telling me, but Ruben, what does that mean? What does it mean to change the background of a color? Well, as you probably guessed it, if I just change BG, now only the background of the letters H, E, and L will make ourselves red, and it will be white in the foreground. Now, again, we can probably change that as we see fit, and that's where we're going to be starting now making the interesting experimentation now, because for the moment, we do have this interesting thing that are hard-coded values inside of the printf command, but as we all know, the printf takes a format. That's why the F is there. F stands for format. So we print a format of a string, which takes values of string to be, again, interpolated inside of that format. Let's take a look at that now, and let's see what we could do, either just to keep the same command, or just make it a little bit better, right? So by default, you probably know that the strings, they have the %s command, so that we know that this is a string position. And so probably what we're going to be using now is we want to make a message that takes a styling, and by the end of every message, we will reset it. So now we have the message itself styled. Next to it, we have the message itself, and then the reset value in here. We could either A, not have it and just have the reset in here, or we just pass it by value. I'll be passing it by value. So what we're going to be doing now is this %s, my God, percentage. There we go, right? So the last command will be the reset value. And again, we have this. Here we have message. And now in here, we should have our styling, right? So right in here, where we are right now, I want to have bold letters. I want to have the underline like this. Did I call it underline or, yeah, I did call it underline. And I want it to be, the foreground will be green. So FG, actually yellow, that will be better. And the background will be cyan, right? So now we should have something like this. This thing over here. Excuse me, where are you right now? There we go, right? So we have this line over here. It's a format string with values appended to them. So this is the first one for the styling. Here is the message itself. And here we have the reset value on the escape keys, right? So now here's the cool thing again. Bop, boom, beam, bang. There we go, message, right? Once again, I forgot to actually add myself the new line. So we can probably add that here. Probably no, we will. So again, insert character, \, there we go. And there we go. The word message has this amazing blue style, right? Really? Blue is 44 and I said yellow. Well, great. We have an amazing terminal, right? When we want to say blue, we say yellow. So let's just see what that did. For that is wrong. So we have 40, 41, 42. Oh, we went 44 twice. So we have this issue even in my cheat sheets. Let me see if I did the same problem here. Well, we have 34, 35. Yeah, so it was down there only. So we have a boo-boo over there. Not a problem. There we go. Really, we still have 44 in blue. Let's see what that did wrong. So now make again. Really? Wow. Well, that's not a good thing. GCC main.c and just, well, we'll just run that a.out. It's still blue, right? That's a problem, right? That's a big problem, right? Let's just take a look at why that is and see what happened. So we do have 44 over here. And again, where could that be wrong? Let's just see. So if we were to do blue now, FG blue. I wonder if I changed them. Nope. Well, now both of them are like that. I think that my yellow is actually closer to white. Let's see, white. Now that is white, and by yellow, okay, so maybe yellow is just a bit, well, less white, but it should be yellow, but it's not yellow. Let's see, background, and background should be cyan. Mine is blue. That doesn't make any sense. So maybe the problem is my terminal window being on Emacs. So yeah, not the ideal situation, but we can probably think about this and see what that will do, right? So as a counterfeit cyan. Let me just pause for a while. Well, let me just pause now. Let's just find out what that is, and I'll be right back. Okay, folks, I've just came back from my experimentation. I just opened another terminal, and yeah, it did exactly that. So the problem is exactly that V term that I'm using right now. It's using the color theming of the editor, so it's not obeying the the standard. But hey, it's what it is. But the command values and the values themselves are okay. They are not the most ideally used for Vmax or vterm and Emacs, but hey, it's our life now. So let's continue now. So these are fine. So the values, they're not the wrong part. So let's now continue on with our experimentation with the ANSI escape commands. And let's just make something a little bit more interesting, right? So now in our artisanal experimentation, we should probably take advantage of these commands and just make something useful for us, right? If we're making an application, if you're making a game engine, if you're making tooling that needs logs, right? It needs error messages to be as clean as possible. We should probably use at least something more sophisticated, right? Not just these hard-coded commands that will be macros for us. We need to have something a little bit more, again, more structured, that is easily debuggable, right? And so for that, we're going to be using, again, functions for this, and these functions, they will be artisanal, right? And so the most important part of the artisanal code is that it needs to be readable to the point of exhaustion. And so that exhaustion in C code is pre-definition on top, implementation at the bottom, right? So we're going to be probably taking advantage of the clean code aesthetic where, again, we read documents as they were newspaper headings, right? So we have the title up there. In our case, that is Artisanal Programming, the ANSI escape codes in C. Imagine reading a book about that. You're going to have an amazing experience, not going to lie. And then the first thing that we do, we include all of our libraries going to be used. We define all of our special keys that are going to be opening these special doors of power of ANSI escape codes. Once that is done, we start our journey in the main function that takes and makes the journey the most empowering exploration in this amazing and journeyous and fantasious fantasy exploration with C code, that is this mess thing. Let's just continue on, for I'm not a storyteller, I am a programmer, right? So the first thing we're going to be doing is we're going to be defining ourselves some functions. Those functions will be the void functions, right? They're all going to be printable functions. And I do like to have all of these printing. Actually, I will print custom functions. So they are going to be messages with a custom styling. And then we have printing a message, printing a debug message, printing an error message, printing a warning, and printing a critical message. So we need 6 special keys. So in that case, we're going to do 6p. Now we have the print commands waiting for us. So the first command will be print custom. Custom takes a string message with the const character pointer as the style, right? And now all the future ones that we're going to have in here, instead of custom, this will be, the first one is obvious, will be print message. And this one will not contain a style, for we will predefine the style. Once we have message, we take the, for messages, then we have warnings. After warning, we do need the, now warning, now the next one will be the debug. Debug will be nice. Debug. After that, we're going to take the, again, message, warning, debug. And then we have error and critical, I think. Yeah, error. and critical. I don't need this one. Right, so we do have the definitions now. Actually, yeah, we have the definition. Now we need to do the implementations. They are all gonna be standard printf wrappers, right? But they are printf wrappers with a good heading, right? So in the end of the day, what we're gonna be having right now is we take this thing, and now down here we will we will add implementations to them, which again are just wrappers inside the printf function, right? So the printf function again, it just takes the message itself. So it will be a S here and an S here, and then we take the message, actually style, message, and last the reset key. So now actually we do need a third one in here, and that's it. Great. So now the custom one is done. Let me just take out a bit of zoom so that is easier for me to read. We do have print custom now. That's it. And that's all the function that we need. Again, it's just the void is just outputting data. We're not going to be messing with saving inside of a file. If we want to do that, you can do that with the kernel itself. That's how it works, right? We're just going to be outputting it into the standard output, right? We're not going to be reinventing the wheel. So the next thing we need to do is print the message. To print message now, we're just going to do, again, pretty much the same thing. Do this, do that. Actually, I forgot to add curly braces. Like this, I don't need that. And now this, there we go. Now we do have print message. So again, we take a style. This style now will no longer be the argument inside the function. Now this one's going to be predefined by us. So a message does not need to be bold, does not need to be stylish. It only needs to be white. So let's just do FG white, and that's it, right? It's going to be plain message inside of our standard output, right? So the next ones that we're going to be using will be warning, debug, error, and critical, right? So obviously, right, the critical is going to have the most sophisticated of styles, and all the other ones are just going to be visual candy, right? So let's just do that. So the next ones that we need to do is we just take this. There we go. I think I can do replace string. I will replace this with this. There we go. And I think I made a boo-boo. There we go. I need to do that again. Replace string. No. Oh no. There it is. Right. I don't want to search anything, so let's just start again. And there we go. There we go. There we go. There we go. All aligned, right? So now we have all of these messages now. Now what we need to do is define the stylish nature of each one. So let's just define the styling now, right? Shall we? So artisanal programming again. Artisanal. So now the artisanal side of warning is we need to have the foreground of the color be yellow. So yellow. Then we have the debug messages. They are blue. Then we have the error, which the foreground needs to be red. And now the critical one is the one that's, well, the nicest of them. So the first one that we're going to be doing is I will be using foreground black, plus the background will be red, and I'll have them be bold. And the error messages also need to be bold. And I'll have, well, I do need to have the bold key be back here. There we go. So it's a bit more structured. Actually, to be fair, I think, no. Yeah, let's just keep that, right? It's foreground, then background, right? So then we have the foreground blue on the debug messages. I do like them to be bold as well. And I think the warnings could also be bold. So bold messages. And that should be enough, right? So now I think that we have everything done. Let's first of all keep that in there. Let's start by implementing a single test, right? Let's just test this out with the obvious one, the obvious message in the artisanal session, right? So print message. Then we're gonna have here the message itself will be artisanal code. There we go. Did I spell artisanal? There we go. Artisanal. So now we have a message, we have warning, we have debug, error, and critical. Again, do the same thing here. We do warning, print a debug, then we print an error, and then we print a critical. Right? Do the same thing again. Make run, and I forgot again a new line. Whoops. I forgot myself a new line. Again, where are you right now? I totally forgot that I need again to use the insert character. There we go. Backslash. There we go. And whoops. There we go now. And now we do have our program now typing artisanal in the terminal with their many very nicely well-defined colors, right? Now, clearly we can see a problem, right? The yellow nature of it is, you can see some yellow in it. It's not perfect yellow, but in your terminals at home, you will probably have more fun than me. Well, it's life. Some parts of yellow are yellowish. Some yellow, turns into mush like this one. But hey, it's visible. We have the visual highlight for this. And we made ourselves our first, in very small amount of lines, logger, right? So this logging now that we have available, we can make many interesting things. And especially the fundamental flaw that we do not have anymore is we have better defined, escape commands, right? Let's be honest, writing this down by hand is not an interesting thing. It's, hard, so let's just make it easier, right? I hope you enjoyed it. See you in the next one. Bye.